Hey guys, so we're going to be moving on to the teachings needed for exercise 6E, and we're going to be going over a couple of circle theorems that you may have come across before, but I wanted to remind you about them because this is the theme of this exercise. So what we're going to be speaking about here are tangents to circles, and then we're going to be talking about chords and perpendicular bisectors. So I've said here there are two circle theorems that are of particular relevance to problems in this chapter. The second one here you may be less familiar with. So for this video, we're going to be focusing on this one that we've got here. And for the second video, we'll be focusing on this, but I'm going to talk about this one in a bit more detail for the next video. So here I have said that we've got a circle and a radius and a tangent, and I think you'll know this one. And this says that the tangent is perpendicular to the radius at the point of intersection. So when it's meeting here, the radius, when it meets the point of intersection, and the tangent, they cross at exactly 90 degrees here. So why will this help? Well, if we knew the center of the circle and the point of intersection, we can then find out, so that's saying we know this and this, we can then find out the gradient of the radius. If we know the gradient of the radius, we know the gradient of the tangent because they are perpendicular to each other. And if we know the gradient of the tangent, we know a point that it goes through, so we can work out the equation of the tangent. This one that I've got here, I'm going to come back to it in a second when we go through some examples that use it. These next two examples are going to be focusing on the fact that the radius and the tangent are perpendicular to each other. So we're just going to use this straight into a question. Okay, a circle C has equation x minus 3 squared plus y minus 7 squared equals 100. First of all, it wants us to verify that the point P 11, 1 lies on C. So this word verify is just a posh way of just saying like check that it's there, check that 11, 1 is on C. It just means to check that it's there. So what we need to do is we need to substitute x equals 11 and y equals 1 into the circle equation. And we just need to see that it's equal to 100. So if I do for part A of the question, if I'm substituting x as 11, so I get 11 minus 3 squared, and if I substitute y as 1, I get 1 minus 7 squared, we're going to hope that this gives us 100. So we can just work it out. 11 minus 3 is 8, so that becomes 8 squared, and 1 minus 7 is minus 6 squared. 8 squared is 64, minus 6 squared is 36, and that equals 100. Hence, P is what P lies on C, because it gives us the answer 100. Now here's the part that's going to be using the new learning that we've just talked about. It says, find an equation of the tangent to C at the point P, giving your answer in the standard form for an equation of a straight line. So we need to find the equation of a tangent at the point P. This is where a sketch can be really, really helpful. So we have a circle. It doesn't have to be a perfectly drawn one. We know the coordinate of C is, what do we know where the coordinate C is? I don't think we've actually talked about that yet. But the center of the circle, we can really quickly tell that the center that we have here is going to be 3, 7, because it's from the equation. And we know a point P. Now, it doesn't really matter where you put P. You could put it in somewhere that makes sense, but we know that it's 11, 1. So it's actually going to be probably somewhere down here, but it really doesn't matter where you put it. So this is P, which is 11, 1. And we're trying to find out what the equation of this tangent is. Now, we know something, that the radius and the tangent are going to be perpendicular to each other. So what I'm going to do for part B of the question is I'm going to work out to begin with the gradient of the radius. So I've just done a little r there to say that I'm doing the gradient of the radius, which means I'm going to be looking at this line that I have here to try and find the gradient. So the gradient of the radius is going to be the change in y divided by the change in x. So I'm going to do, I don't know, I'll do this one minus this one divided by this one minus this one. So that's 1 minus 7 divided by 11 minus 3. 1 minus 7 is minus 6, and 11 minus 3 is 8. So that is minus 3 over 4 when we simplify it. Now we're going to work out what the gradient of the tangent is. So I'm just going to do a little t there to show that it's the gradient of the tangent. Now, if they're perpendicular, you should very quickly be able to tell me that if the gradient of the radius is -3/4, then the gradient of the tangent is the negative reciprocal, which is 4/3. Now, if you remember what you need to be able to do an equation of a line, you do y minus y1 equals m brackets x minus x1. So you just need two things. You need the gradient and you need a point. Well, we've already got the gradient because we've got that here. And actually, we've already got a point because we know that it's passing through that particular point that we have. So I'm just going to go straight in and say what the equation of the line is. So the equation of the tangent is just going to be y minus y1, which is 1, equals 4/3 x minus 11. Now, probably the best way to solve this equation is to get rid of this third bit here by multiplying the whole equation by 3. So we get 3y minus 3 equals 4 brackets x minus 11. And then I'm just going to expand and collect everything together. So we get 4x minus 44. Now I'm probably going to put everything all onto the right-hand side just because it's led with x as the positive. So I'm just going to put everything onto the right-hand side. So I get 4x minus 3y, and then I'm going to add that 3, so I get minus 41. Now let's actually see if this is true by going on to Desmos. So if I go to Desmos, let me just quickly remind myself. So what's 4x minus 3y minus 41? So I've already prepared this, and I'm now going to say 4x minus 3y minus 41 equals 0. Okay, great. Looks like we've got a tangent here. That was the center of the circle, and let's see if they are meeting at 10, 11. I don't know why they're not actually able to let me show that intersection, but you can clearly see that not at 10, 11, sorry, at 11, 1 is where the tangent is. So we've actually come up with that equation of the tangent that we've got there. I'm not quite sure why Desmos isn't allowing me to show that they have an intersection, but we can see that there's a tangent at that point that we've got there. Okay, so let's have a look at another example. Here we have a circle that has this particular equation, and it's equal to 10. We've got x minus 4 squared plus y plus 4 squared is equal to 10. And you should very quickly be able to gather some information from that question. We can say what the center is. So the center of this circle is going to be 4 minus 4. That's probably going to be useful. So it says the line L is a tangent to the circle and has gradient -3. Find two possible equations for L, giving your answers in the form y equals mx plus c. So I actually think a sketch is going to be really useful here to think about why on earth are there two possible equations. So let me draw a circle. I forgot I had this circle tool here. Now, if it has a gradient of -3, it's going to be a sort of sloped downwards line like this. And so there's going to be two places where it could have that gradient. There's going to be one place here, and there's going to be another place on the other side where those two lines would be parallel. And we know some other bits about this question, okay? We know that these gradients are -3. So let me just say this one is going to have the gradient of this tangent is -3. And we also know that the center of the circle is 4 minus 4. So we could, I suppose, figure out what this equation is here. That could be really, really helpful for us because we know that the gradient of either the diameter or the radius is going to be related to this gradient that we have here. So the gradient is going to be a third. Now I'm hoping that you might see that this is going to be important to work out the equation of this line. Why do you think we might want to work out the equation of this line if ultimately we're trying to find out the equation of these lines? The reason is because if we know the equation of that red line and we know the equation of the circle, hopefully what you're seeing here is we're going to be able to work out this coordinate and this coordinate. And because we know the gradient of these lines, if we know a coordinate and if we know a gradient, then we have got the equation of the lines. So I'm just going to write down what the strategy is for this question. So the strategy for this question, number one, is to find the equation of the of the line through the center, which is perpendicular to the tangents. Then what we're going to do is we will find the intersection of this line with the circle. And then what we will do is we will use these to find the equations for L. Okay. Difficult to see in these questions. You're willing to draw a diagram and sort of solve this problem like it's a puzzle, really. So we're going to find the equation of the line through the center, which is perpendicular to the tangent. So the first thing that we've said is that MR is a third because it's a negative reciprocal of the tangential one because they're perpendicular to each other. So the equation of that line is going to be y minus y1, which is y minus minus 4, equals m brackets x minus x1. So we're talking about the center of the circle here. So it becomes y plus 4 equals a third x minus 4 over 3. And because we're going to try and solve this with the circle equation, we're going to need to put it in as a y equals. So I'm going to have to do here minus 4 over 3, subtract the 4. So I get a third x minus 16 over 3. Oh, in fact, I probably don't even need to do that. And I'll say why in just a second. So that was number 1. We found the equation of the line through the center perpendicular to the tangents. Number 2, what we're going to do is we're going to find out the intersection point. So I want to know, where does this and this intersect? So you're going to solve them simultaneously. So we've got x minus 4 squared plus y plus 4 squared. Now the reason I said I probably didn't need to rearrange that is because actually here I've already got what y plus 4 is. So actually this one that I've got down here is less useful. So I'm actually going to just use the y plus 4 one immediately, which is a third x minus 4 over 3 squared equals 10. So that becomes x squared minus 8x plus 16 plus 1/9 x squared. Now this bit's probably a bit trickier to see, so we're going to have 2 lots of minus 2 lots of a third times 4/3 x. If you need to expand that more slowly, then you should do. And then we've got plus the 4/3 squared, which is 16 over 9, and that is equal to 10. So let's just simplify this a bit. We get x squared minus 8x plus 16 plus a 9th x squared minus 8 over 9x plus 16 over 9 is equal to 0. So adding all of these bits together, we've got x squared plus 1/9 x squared is 10/9 x squared. And then the next bit, I've got minus 8 minus 8/9. Minus 8 minus 8/9. So that's minus 80 over 9 x. And then I've got 16 plus 16 over 9. So that's 160 over 9. You could have done this. We could have maybe multiplied everything by 9 at one stage. That might have made things a bit easier. Whoops. And this isn't equal to 0, is it? It's actually equal to 10. So really what I should have done is I should have subtracted by 10. So let's just subtract 10 as well. So 70 over 9. Okay, so I could multiply everything by by 9. So I get 10x squared minus 80x plus 70. And I could also then divide everything by 10 if I wanted to. But remember, you've got your calculator. So if I then go into the calculator, and I'm just going to say a is 1, b is minus 8, and c is 7. I could have just factorized this, but I'm being super lazy. We get that either x is equal to 7 or x is equal to 1. Now, if x is equal to 7, we need to find out the y coordinate. Y is going to be equal to, this is using this now, we've got a third multiplied by 7 minus 16 thirds. So that's 7 minus 16 over 3, which is minus 9 over 3. So it's minus 3. So we've got one of the coordinates is 7 minus 3. And if x is equal to 1, then y is going to be a third multiplied by 1 minus 16 over 3. So that's 1 minus 16 over 3, or minus 15 over 3, which is minus 5. So we have 1 minus 5 here. Okay, let's just remind ourselves what we're actually doing. So we have now found out that we've got these two intersections. We've got one of them as 7 minus 3, which is going to be this one here, although it doesn't really matter which is which. So this is 7 minus 3. And we've got that the other one is, what did I say? It was 1 and minus 5. So this one here is 1 and minus 5. That was number 2 that we did. We found the intersection of this line with the circle. So we are now on number 3 to find the equations for L. Now, for the equations for L, all we really need to do to find this one is we know what its gradient is and we know a coordinate. And for the same, we know what its gradient is and we know what the coordinate is. So that's why we're going to use the equation of the line again. So for this third part, the equation of L, we know two things. That the gradient is minus 3, and we know the points that it's going through is this one and this one. So our first equation is going to be y minus 3, or y plus 3, equals m brackets x minus 7. Now technically that's the equation of the line. If it doesn't ask for it in a particular form, oh, it does go to a particular form. Once it is y equals mx plus c. If it didn't ask for that, you could technically leave it there. So that's y plus 3 equals minus 3x plus 21, careful of the negatives. So y equals minus 3x plus 18. That's one of the equations. The second equation is y minus y1, which becomes y plus 5. We're using this coordinate now, equals minus 3x minus 1. So we get y plus 5 equals minus 3x plus 3. So y equals minus 3x minus 2. So we have these two equations here and here. I'm actually just going to check that this has completely worked by going back to Desmos and seeing that it's right. So we've got x minus 4 squared, y plus 4 squared equals 10. X minus 4 squared, y plus 4 equals 10. And we've got the equations where y equals minus 3x, y equals minus 3x minus 2, and y equals minus 3x plus 18. So here is our circle. Here are the two tangents. Both of those lines have a gradient of 3. We've really answered the question fully there. So I'm going to stop at this point because you can see this topic is becoming quite a lot more demanding. But if you didn't have this diagram, I think this question would be really hard to think about what is going on. These don't always tend to follow particular routes all the time. So you really need to draw the diagram and think, what do I know? How is this related to this circle theorem that I've got here? And what do I know about equations of lines, etc., etc. Okay, so we're going to come back in a second and we're going to use this second circle theorem that we have here.